Okay, let's take a look at problem 2, which says a uniform horizontal beam is 8.8 feet long and weighs 258 pounds. It is supported by columns at either end. A vertical load of 3,570 pounds is applied to a beam at a distance of x feet from the left end. So find x so that the reaction at the right column is 1,590 pounds. Okay, so we know the length of the beam is 8.8 feet. The beam weighs 258 pounds. So I just put that information over here on the right side. Okay, so we want to find x, and x is the distance from the left end to this weight that's being applied. And we know the reaction at the right end is 1,590 pounds. Well, we could do lefts are equal to rights, which we don't have any, or we could do the ups are equal to the downs, but we want to know a distance. And the ups are equal to the downs does not include a distance, and so they're really not going to help us. So what we really want to do is our clockwise is equal to our counterclockwise. Okay, since we don't know the reaction on the left end, then I would hold this beam here on the left end, especially since we want to know x, and that's the distance from the left end to this force. And so let's hold the beam here on the left. It'll make the problem easier. Okay, so if we're holding it here on the left end, we need to look at clockwise is equal to counterclockwise. So our clockwise forces would be this weight that's pushing down, but also the weight of the beam. And so we're going to have these two forces, so force times distance plus force times distance. So the first one would be 3,570 pounds times x feet. And then the second force would be the weight of the beam, which is 258 pounds, and then times the distance. But since this is of uniform weight, then we just take the entire length of the beam and divide by 2, because that's the balancing point of that beam. So that's where we're going to apply the distance. Okay, so that takes care of clockwise. Now counterclockwise. Counterclockwise, we have this force pushing up, and so that force is 1590, and then times the distance. Well, from that point to where it's pushing up is 8.8 feet. So now we have an equation. They're all numbers except for the x. We can solve for x, and we get x is 3.6013, and so on, feet. Okay, please take a look at problem 3. There's, I would say, an unexpected turn in problem 3. So take a look at it, see what you can do, and then come on back and watch the next video.